Okay. Today we're talking about a theorem called corresponding parts of congruent triangles are congruent. Okay? Kind of a mouthful. Now here's the thing. We're not doing a ton of proof in here. We've done, I think, maybe one together. Maybe a couple. But proof is a really big thing in geometry. Geometry is all about saying not only what do you know, but how do you know that it's true? Okay? That's really one of the big pushes for geometry, is not just being able to say, this is the answer, but this is the answer and here's why we know it. Today is all about why do we know this is true? Okay? You're going to look at these problems and be like, oh, I know the answer. That's really easy. The answer does not matter today. The reason why you know it is what matters. And that's what this is going to be all about, is corresponding parts of congruent triangles are congruent. Okay? Let me give you a abbreviation for that. I know you love abbreviations. The abbreviation is, just use the first letters of everything, CPCTC. Okay? CPCTC. Corresponding parts of congruent triangles are congruent. So probably that's the last time you'll hear me say that whole thing out in one sentence. Okay, usually I will say it as, let's see, you're going to watch it flip for a second. Usually you're just going to hear me say the abbreviation. And here's what that means. That means that once you know triangles are congruent, you know that all of their corresponding pieces are congruent. We've sort of already talked about that. But now that we've talked about our triangle congruence theorems, it makes a little more sense. It's a little more useful. How many pieces do you need to tell if a triangle is congruent to another triangle? 3. Yeah. Like all of your triangle congruence theorems, SAS, SSS, ASA, they're all 3 pieces, right? Okay, except HL, but we're not even learning HL, so don't worry about HL. Because actually there is a third part to that too. So you need 3 pieces to tell if triangles are congruent. But how many pieces does a triangle have?
3.
Nope. 6. 3 sides and 3 angles. So what CPCTC is all about is once you know 2 triangles are congruent using one of those theorems, you'll need 3 pieces of them to be congruent. But CPCTC then says that all of the other pieces are congruent as well. So let me show you a quick example. Go ahead and write this down. I'm giving you 2 triangles. I'm going to give you this and this, and this and this, and that and that. Okay? How do we know those triangles are congruent? Okay, but what theorem?
Angle, side, angle.
Angle, side, angle, right? That those would be the angle, side, angle triangle congruence theorem. Now that I know that, now that I know those 2 triangles are congruent, I can also go back and say, okay, now I know these 2 sides have to be congruent, and I know these angles have to be congruent, and I know these sides have to be congruent. So those new markings, the ones that I put on there in blue, that's what CPCTC is all about. Okay, it's about saying, all right, I got my 3 pieces, which meant my whole triangle was congruent. And then after you know the whole triangle is congruent, you can go back and say those other pieces that you didn't know anything about before. Now you can say that those are congruent for sure. Okay? Does that make sense? What CPCTC is trying to say? Okay. So again, why didn't it switch for you? Oh, now it did. Okay. Remember those theorems, the SSS, SAS, ASA, AAS, and again, don't worry about HL, you don't need to know it. Use those corresponding parts to say that the triangles are congruent. CPCTC comes after that. Okay, so you use CPCTC after you use one of the other theorems. Okay, you're not going to ever say these 2 triangles are congruent because of CPCTC. You're going to say they're congruent because of one of these, and then use CPCTC after that. Okay?
So
are we doing? You still have to do the SSS, and then you just write CPCTC.
Well, yeah, I mean, depending on what the question's asking you, but yeah. So A and B are on the edges of a ravine. Okay, so this is really a method that they use, like surveyors use to do this. Let's suppose there's a ravine cutting right through here, okay, big giant pit. And we want to know how far apart these are without having to climb over the ravine and measure. So surveyors use this method where they go to the other side over here, and they visualize it. They have tools that let them get, these angles correct, and they line this up.
18?
It would be 18. Yep. But let's talk about why you know that.
Because the other side is 18.
How do you know?
Because I'm looking at it.
Okay, but how do you know this side has to equal this side?
Because they're triangles and they're congruent.
Okay. Well, how do you know the triangles are congruent? This is a question for everybody.
I know.
How do you know the triangles are congruent? Go ahead, Darren.
Is it angle? Because it's vertical.
Okay, you've got a vertical angle here. Here, maybe I should put it so you can see it. Okay, you've got a vertical angle here, right?
Yeah.
You've got a 15-mile side here and 15-mile side. Yep. And then here, this side, this 10 miles would be congruent to this 10 miles. So I can say the triangles are congruent, okay, by triangles are congruent by side angle side. Go ahead, write this down. Triangles congruent by side angle side. And so now that I know the triangles are congruent, what do I know about that AB distance and the 18?
It's 18.
It has to be 18 because now I know those triangles are congruent. Okay, so that's why I know it has to be 18. So AB has to equal 18 because of CPCTC. So do you see what I mean? That the answers to the questions are going to be really easy. Like Darian took one look at that and he said, oh, it has to be 18. But what I want to know is why does it have to be 18? Okay, that's what we're focusing on today is the why. Not so much the answer, but the why. Okay? Let's try another one. A landscape architect sets up the triangles shown in the figure to find the distance across the pond. Okay, so once again, that distance across the pond is a distance I could not go out and measure. I'm not going to drag a tape measure across a pond. But I can set up these triangles in this way so that this works out. And then what would JK have to be?
41.
Would have to be 41. Why?
Why? Because it's side angle side.
Okay, so the triangles are congruent again by side angle side, right? And then the 41, or the side MN, would have to be congruent to the side JK because of CPCTC. Okay? So again, triangles congruent by side angle side. Not always going to be side angle side, but in that particular method it works well. Okay, triangles congruent by side angle side. And then we know JK would have to equal MN by CPCTC. Okay. And so I know that JK is equal to 41. Good? So nothing super new today. Just a different way to use the same information that you already know. Last thing we're going to look at is a proof. Okay, so have you seen at least one of these before? I said I don't know that we've really done that much more than one, but I know we've done one of them.
Yeah, but we didn't know how to do it.
Okay, well I'm going to show you. Okay, given J is the midpoint of KM and NL, and I want to prove that KL is parallel. By the way, that symbol right there means parallel to MN. Okay, and I'm actually going to sit down for this so that I can write better. Okay, here's how a proof works. A proof works by taking what you're given, that's like your starting point, and then working your way to what you're trying to prove using facts and theorems and definitions and all of those things that you already know. Okay? So the very first step to a proof, you're going to want to make sure you write this down. Okay, I think for you it's actually on 2 different slides. Like I gave you the given and the picture on one slide and then the proof is on the next. Okay, but your very first step is to write down what you're given. Write down your given information. So step 1, I would say J is the midpoint. I'm abbreviating midpoint of KM and NL. Given. Okay. Always the first step to a proof. Write down what you're given, and then the reason you know that is because it's given to you. Whoever is making you write this proof, whatever cruel person, is telling you that this is true. Okay? Okay. I'm going to, just to get you thinking about this, I'm going to kind of start you at the end and work backwards. If I want to show that KL is parallel to MN, how would it be helpful to know that this angle is congruent to this angle? Why would that be helpful to me? Don't have any idea? How would this angle and this angle being congruent tell me that those lines are parallel? Jemijah, what did you say? Okay, across, not vertical, but there's a different name for them. Nope, angles aren't parallel.
Adjacent.
Starts with an A. Rebecca?
Is it interior angles?
Alternate interior angles. Yeah, if I could get these 2 angles at angle N and angle L, if I could get those 2 to be congruent, then my lines would have to be parallel because they're alternate interior angles. Okay? Now, to get those angles congruent, my general method, and this comes up in proof a lot, is I'm going to show that this triangle up here is congruent to this triangle somehow. To do that, I'm going to have to use like SSS, SAS, one of those. I'm going to somehow show that this triangle is congruent to this triangle. And then I'm going to use CPCTC to say, okay, that means this angle must be equal to that angle. Okay? So my ultimate goal here, or my first step, I guess I should say, is to get those triangles to be congruent. So let's start with what we're given. If J is the midpoint, what does a midpoint do?
Oh, it's where the angles meet.
Close. What does it mean if it's the midpoint of something?
Middle.
It's the point in the middle, right? So if this point J is in the middle of K and M, what do you know about the distance from K to J and the distance from J to M?
It's gotta be like
It's got to be the same, right? That J cuts it in half. So I know KJ has to be congruent to JM. That's going to be my next step. So KJ has to be equal to JM. And that I know that because that's what midpoint means. Midpoint means the point in the middle. It means it divides it into 2 equal pieces. Anytime you're using the meaning of something, anytime you're saying that's what that word means, that's a definition. So I knew that was true because of the definition of midpoint. Okay? Definition of midpoint is how I knew that KJ was equal to JM. Now I also know that J is the midpoint of LN. Okay, J is also the midpoint of this. See how it gives me both of them? It says it's the midpoint of both segments. So if I know J is the midpoint of this segment, what else do I know is congruent? Not KN. Nope. If J is the midpoint of LN, what other pieces have to be congruent?
KM.
Nothing with K. I'm dealing with J, and then from L to N.
JM.
Okay, JN is congruent to this piece would be equal to, Hunter? JL, good. This piece is equal to this piece. Okay? 3 JN is equal to JL. And still, that's the definition of midpoint. Okay, definition midpoint there too. And so now I'm going to mark that in my picture. Now I know those two are congruent. Okay, thinking about this from like your congruent triangle standpoint, what other piece of information would be helpful to us here? If you're trying to get the triangle on top and the triangle on bottom to be congruent. Okay, KL and NM, that'd be nice, but I don't have any way to find that those are congruent. What else is in this picture that I can use? Rebecca? Okay, which angles? You're right, it's vertical angles. Do you know which two I'm talking about?
Yeah, the ones in
So this and this are what I'd be looking at. Okay, is that what you probably were having a hard time saying which one it is? And remember to name an angle in this, I can't just say angle J because there's a lot of different angles at angle J. So I'm going to have to say, I also know angle KJL, which is talking about that top angle, is congruent to angle MJN. And I know that because of the vertical angle theorem. Okay. Now do I have enough to say my triangles are congruent?
Yeah.
Somebody name that top triangle for me. The triangle. So KL.
KL.
How many letters you need to name a triangle?
2.
No?
Three.
3.
KJL.
KJL. So triangle KJL. And this is where we have to be careful. In this triangle, we went from K to J to L. So to name that bottom triangle, remember I have to name it in the same order.
So
MJ
Nope.
NJN.
This triangle, hold on. This triangle, we went the side that I marked with 1 hash mark and then the side that I marked with 2 hash marks. So MJN. They go backwards. This one goes this way, this one goes this way. Does make a difference. So this is congruent to triangle MJN. And which triangle congruence theorem is that? Those are your, like, the ones we've been talking about. SSS, SAS, ASA.
Oh, S.
A.
Nope. Rebecca?
SAS.
SAS. Good. Okay, SAS tells us the triangles are congruent. Now I can say that these little angles are congruent. So I'm going to say angle JLK, talking about this angle up here, and angle JNM. So now I know the little angle, JLK, has to be congruent to angle JNM. What's my reasoning for that? Now that I know the triangles are congruent, how do I know the pieces are congruent? Rebecca? There you go, the new thing we learned today, yep. CPCTC is my reasoning for that. I know triangles are congruent. So now I know their pieces are congruent by CPCTC. This is how this almost always shows up in a proof. You've almost always got a triangle congruence and then right after that saying that some piece is congruent to some piece. And then my last step is what I was trying to prove in the first place. That KL is parallel to MN And that piece you already gave to me, that's because they're alternate interior angles. So I'm just using,
I ran out of space.
okay, just squeeze it in someplace. You've got an extra box there, so. Okay. So your final step is that those are parallel by AIA. That was a pretty complex proof. Okay. Now I'm not expecting that you would be able to write one of those from scratch by yourself. But do you think if I gave you something like that with just some blanks in it, like some of the theorems that you had to fill in or some of the statements, that you could handle it?
No. Yes.
Eventually you will. Okay, with some more practice. Okay, that's really it for new material today. I did, well,